Our next speaker is going to talk to us about the Mythical 5 Nines. He is a owner and founder of Autoscaler. That's the name of your company, CEO of Autoscaler. So let's welcome to the stage and get us back on track, Steve Fox.
Thanks, sir. Noxious. They gave us these cool belt buckles, and I thought, if we're going to do that, we're going to do it right. So I'm excited to be here. I've done numerous presentations over my career, but first time I've done them in boots, and it's my first DevOps. And it's kind of a milestone for me because the first time I went to a DevOps Days was down in Austin. Here's the shirt. It's all in Spanish. I think it was like 2013. Probably some of you were down there. But it was one of the most humbling experiences of my life because I sat in there and realized I didn't have a clue. I thought I knew what DevOps was, but I didn't. So I sat in these meetings and I sat in the things and I was like, half the time I'm on my phone, just what does that mean? What does that mean? What does that mean? So to be up here speaking, giving back to a community that gave me so much is pretty cool. Now, I know somebody asked before, how many first-timers at DevOps do we have here today? Quite a few. All right, so statistically speaking, one or two of you are going to be up here speaking in 2 to 3 years. So do me a favor, even though you don't believe it, save your shirt and wear it on stage, and let's keep passing this stuff along. All right, so let's get into this stuff, the whole mythical 5 nines. Clicker. There we go. First little 5-9 humor. Read it quickly. That's how we feel sometimes, right? How did we become so obsessed with all these nines? I mean, they're all over the place. I love this clock. I want to get it. So this talk's going to be a little bit about the quest for availability, the history behind the 5 nines. We're going to do a little bit of myth versus fact, hopefully bust a few myths along the way. But if nothing else, hopefully give you a new perspective about the whole 5-9 thing. So let's talk about application quality. Surely we would agree higher availability is better, right? Whatever number you want to put to it. Fewer errors is better, and fewer slow responses is better. I don't think anybody's going to argue with that. So if we take that to its logical conclusion, perfect quality would be 100% available, 0 errors, and 0 slow responses. We finally got there, right? It's the perfect system. What more could you want? Here's the first curveball I'm going to throw at you. Quote from Winston Churchill, other people have said it, but perfection is the enemy of progress. That's right, I'm going to follow a quote from Winston Churchill by one from Stewie Griffin. And I misquoted him at that. But hold on a second, what are we talking about here? Progress? Progress of an application? Let's talk about it in terms of success. Why do we build this application in the first place? It must be doing something. What about profitability? If we had a perfect system that lost money, how long are we going to be running it? What about market share? Right? That's important. So if we, and a lot of you are probably like, ooh, that's that icky, touchy-feely business stuff, Steve. I'm in DevOps. I want to sit in my cube and just like churn out code through my pipeline. Well, sorry, but the decisions we make in DevOps have a pretty big impact on the business. So let's break this down a little bit into things that we actually kind of have better hands on in DevOps. So profitability, without getting into accounting stuff, is basically revenue minus the cost, right? Market share is about being responsive to market needs. It's about solving a meaningful problem, and eventually, if you do that well, it will drive revenue. So if we boil that down, it's really about operational costs, because that's a key component to profitability, and it's about velocity, something we talk a lot about in DevOps, right? It's how you get market share because you keep up with things, you're ahead of the competition. So interestingly, a little unscientific survey here. So when I said the perfect app earlier, did anybody in their head have any sort of thing of cost run through their mind? Like, whoa, you missed cost. Show of hands, nobody thought about cost. We don't have any business owners here then, do we? That's usually one of the things that comes to mind. How much does it cost to operate these applications? Velocity is the other one. So, a little question for you. Would chasing 5 nines affect either one of these? A little precursor. We'll come back to that. So let's run into this. What's the definition of 5 nines? It's the number of nines in the availability. What does that correlate to? It's 26 seconds of downtime a month or 5 minutes a year. Not that much. What's the origin, the history of this? It came out of the telecom industry in the 1990s, and it started with the hardware side of things. It became synonymous with carrier grade. If you're going to put hardware into the telephony system, it had to meet 5 nines. But why? It's because of this need to manage the cascading failures kind of things. So to understand that, let's do a little bit of math background. If you have multiple components in a system, the system availability is the product of those. Now, hopefully you can build systems better than 50%, but it's a good example. You have two systems that are only up 50% of the time, but they both need to be there to function, then your system availability is only 25% because half the time one of them's down, right? So as you start to build out telephony systems with like 3 nines goes to 99.8, but as they start to chain these things together, which you have to do in telephony systems, you start to really lose some reliability along the way. So by the time you get up to 10, you've actually lost a 9. You started off with 3 nines, and now you're at 2. So if you have parallel components, it's a little different story. The equation's a little more complicated. But at the end of the day, we all know this. If we run things in parallel, we have reliability because if one side fails, the other side can pick it up. The problem is this gets very expensive because both of those have to be completely independent, and it will at least double your cost in most cases. So a myth is born. Somewhere along the way, the 5 nines jumped from the hardware component to the entire network system level. Not sure exactly where this happened or why, but it looked to be driven by this competitive sales and marketing pressure because it just sounded cool. Our network is 5 nines. A lot of times there's financial penalties if you don't meet the SLA, but oftentimes they were small relative to the contract value, so people would just overcommit knowing they wouldn't make it and still make money off the deal, right? It's a business deal. One example was they'd protect themselves with fine print. There's a reference to this if you want to go check it out, but one vendor, which shall remain nameless, they put out 5 nines of availability. Then you read the fine print. Refunds only paid if an entire hour of outage is out. If you do the math, that's 99.85 is what they're actually doing. A little bit of marketure. So if you're going to do Family Guy, you got to throw The Simpsons in, right? So want versus need. We all want our systems to be working 100% of the time if we could flip a switch. But do we really need them to? Can we really expect them to? And how much are we willing to pay for them to do this? 2 times, 3 times, 10 times? 5 nines is typically rooted in a want, not a need. And is it even realistically possible? So ITIC did a survey, 44% of outages, human error. Or sneezes. Bless you. Can you fix a human error, something that we caused in under 5 minutes? I don't think so. Not to pick on Amazon, but the infamous S3 outage back last February. One wrong command, one wrong parameter on an admin command brought down S3 for 4 hours, right? Prior to that, they were actually exceeding their published SLA. So how well do these telephony guys, the mobile service providers, do? They don't quite get 5 nines. About 98.8 is their average. Interesting stat here, if you look, Dallas, out of the top 10, highest. We're up at 99.4. Probably because we have some of the AT&T execs here is my guess, but I don't know. What about the ISPs, the hard lines, where you don't have all that wireless stuff to deal with? How do they do? Well, they're closer to 3 nines. Google estimates somewhere between 0.01 and 1% failure rate. That's somewhere between 2 to 4 nines. So this brings up an interesting point. If we build a system that's 5 nines and we have consumers as our customers, will they even notice if their ISPs are 3 nines? Probably not. So here's a little tip. Maybe consider how you do your error strategy. Please, please, please do not do this. I still see this from time to time on sites, and I'd love to put a little LinkedIn message to the CTO and say, oh, by the way, you got a null pointer exception on file 654. Started some interesting conversations, I will say. Better would be to do like this. Amazon, we all came to know and love the dogs of Amazon. But here's an idea. What about no response at all? What if you just, when things go bad, you just kind of they might blame it on their ISP. They don't know. Let them take the heat. Now, if you do this, be careful, because what do we all do? We hit refresh, right? And we give it a second try. But after 3 or 4 attempts, we're going over to Google. Is everybody else still working? So if you do this, like, do it in your session and make sure, I'm like, okay, I'm only going to do it once or twice, and then I'm going to fess up. Whoop, all right, I got a 500 page, but. All right, well, how well do the cloud people do? There's their published SLAs. In general, it's 3 nines. The best on this list is AWS region, but that's only if you're running in 2 different availability zones. That's the only way you can get better than about 3.5 nines. So now, I'm poking a lot of fun. There are a lot of true 5.9 systems out there. Banking, healthcare, airlines, I mean, things when people die or things seriously happen, we have a lot of 5.9 systems out there. But my contention is the consumer of these systems is not coming over the public internet, or you wouldn't be able to get it. So for most cloud apps, it's an overspecification, I think. And it can be done, but now you're talking multi-region, lots of mature DevOps, and it gets expensive. So the question is it worth that extra cost and complexity? Or 4 nines, is that even justified? So let's go through like a hypothetical little xyz.com. They do 100 million annually, and the CTO and the CFO come in. Oh, we need 5 nines because every minute we're down, we have loss of revenue. Well, let's do the math. If you have 100 million annually, that correlates to about $190 a minute. So let's assume roughly 25% of your revenue is in DevOps costs, so that's like 25 million. To go from 4 to 5 nines, we're talking 52 minutes to 5, you're probably going to spend at least 10 million. A lot of times you're doubling the cost, but even conservatively, you're going to spend 10 million to save 10K? So when you do the math, a lot of times these things start to fall apart. That's the only way to pull it apart. Here's the other thing to be careful of, the big number rationale. So poking a little fun here at Amazon, but they had the Amazon Prime glitch that you probably read about. And I was amazed at how many stories and blog articles came up just about how they just really screwed the pooch, metaphorically. So they say that about 72 million in lost revenue is what they estimate. Wow, that's a lot. Surely they needed 5 nines, right? Well, you look at the other side, though. They estimate they did 4.2 billion with a B. Put that on a chart, somehow that little glitch doesn't look so big anymore. It's 5 nines. On top of it, their revenue went up 74% year over year. So do you really think they're sitting around Seattle going, dang, we really messed up. We could have had 76% growth. I don't think so. But if you look at it, it's 98.3 is what they actually achieved. Yeah, they probably want to do better. 3 nines makes a lot more sense. And I'm sure the customer sat, brand recognition, they'll probably do a better job next year. So hopefully we've kind of busted the myth for 5 nines for most systems. If you have one out there and there's a good need for it, go ahead. Now let's focus on the cost side of things. I've always found it fascinating that there's a lot of corollaries between a lot of the physical sciences and the stuff we do in software. And I'm not the first one to bring this up, but there's a real strong correlation between Newton's laws of motion and what we do in applications. So if you think of the first law, Objects tend to stay at rest until an outside force is applied. Well, if we think about it in terms of applications, applications tend to run reliably until we start to change them, right? When we apply force, things change. Why do so many companies do a freeze during the holidays, right? Just don't touch it. It'll keep working. The second law is momentum change is proportional to the amount of force applied. The more we push it, the more it moves. The more we change, the more likely something is going to break. So if you accept these tenets as kind of like a fundamental law, then you have to come to the conclusion that velocity and availability have an inverse relationship. The faster we move, the more we're going to cause problems. The more we try to keep availability, the more we're constrained to not change as much. So velocity loss is the largest hidden cost of chasing the 5 nines. We don't realize we're paying it, but that's where the money or the cost goes. So SRE, Site Reliability Engineering, they have the concept of an error budget, which explicitly manages this relationship. And I'm going to spend the rest of this talk talking about that concept. So for people that don't know, Site Reliability Engineering, SRE, it's a term coined by Google. And it's essentially, from my point of view, it's how they do DevOps. They don't call it DevOps, but essentially it's their version of what they do. There's a free online book, which I highly recommend. If you're interested in any of this, it's at that link. There's a book coming out. It's not published yet, but I looked at the preview on it. It looks pretty good, called Seeking SRE, and that's the link to it as well. It should be published next month. And there's a whole bunch of tenets to SRE. I'm going to only cover one, and it's this one, which is pursuing maximum change velocity without violating a service's SLO. So a little bit of terminology, because we all hear SLA, but we don't always hear SLOs. And SLI is a service level indicator. This is a metric, any metric for measuring quality. We'll use for an example here an error rate. Service level objective, this is a threshold on that metric. So here, a maximum error rate of 0.1%. This would be 3 nines of success. Then the SLA is the contract. This is the government side or the contractual, the legal side, where you have a set of SLOs that make up a contractual obligation. So typically you're not violating an SLA. If you are, you're like violating legal agreements. You're violating an SLO. So now that we have that out of the way, everything else we talked about in availability was always in terms of time, but this SRE definition shifts just a little bit to say instead of like percentage of time up, let's do percentage of successful requests. This gives you a little more granularity because you might not have an outage, but 10% of your customers are still getting an error message. That's a partial outage. So if you look at error budgets, they're essentially an engineering approach to managing service risk. What you do is you translate your SLO into an acceptable error count. So let's say we have 3 nines. We have an error rate SLO of 0.1%. Our system takes 1 million requests a month. You do the math. It says, all right, we're okay if we put out errors on 1,000 requests a month. That's your budget. Now, side note, if you had 5 nines, you'd only have 10. A lot less to work with. So what do you do with this budget? Well, you treat it like an organizational asset, similar to a financial budget. And what do you spend it on? Maximizing your velocity. How do you do that? So when you start off, whatever increment you want to use, let's use monthly. You start off with a big budget. So you increase your velocity, you take more risk. You put in more features, less QA, larger canaries, you just simply move faster. As fast as your DevOps practice will let you go. And as you do that, you're going to start triggering errors. You're going to push something that caused a small problem and you're going to roll back, but you paid for it a little bit. As you consume your budget, you slow down. Less features, a little more QA, smaller canaries, watch it longer, you just move slower. And if you go through your whole budget, stop deployments. This could be a little tricky. This is where you get to have management buy-in. Like, what? We're stopping? Well, if you're committed to your SLO, that's what you do. Now, you don't stop work. You don't go to the ping pong table. What you do is you shift your type of work into more analysis on where did the budget go and why. and in tooling to make sure you don't spend it that way next month. So here's an example of an error budget. You're tracking along, and all of a sudden, a week or two in, you have a big problem, burn through half of your budget in one day, and you find out that you did a deployment and they had no canary, they just pushed it out, and all of a sudden, failures were happening. Burn through it quickly. So then you go along the rest of the month, but eventually you get to the end, and you have zero budget left. Do a deployment freeze, no more. In this case, it turned out good because you had DevOps days to go to. You need to get out of the office anyway. So what they do is give you a very intelligent trade-off between velocity and availability. Some errors are good. They're showing that you're increasing velocity. Don't treat every error as bad. So then there's some practical considerations that come up, though. What if your errors are coming out because of a third party? Does that go against your error budget? You have to decide this organizationally. I would say if you can, try to absorb it because your customer is looking at your SLO. And if you can absorb it, great. But if you're not, that's your decision. So what about an unspent error budget? You're at the end of the period and you got extra left over. Ah, cool, we're really killing it. We're over-delivering on our SLO. What do you do with it? What? Happy hour. I like that. Here's a strange one. Consider introducing errors manually. Why would we do that? We worked so hard to get here, and now you're telling us to put errors into the system? Well, it keeps dependent services from assuming a higher SLO based upon history. So a couple examples here is S3. Part of the reason they got so much press during that outage is people had become to be dependent on it. There were websites that went down because they assumed S3 was going to always be there all the time. If they had introduced a few errors along the way, people might have said, ooh, we need cross-regional support if we really want better than 3 nines. Google's Chubby, which is a distributed lock system, they do this on a regular basis. They're like, oh, we did pretty well. Let's introduce a few errors just to make sure people don't get too dependent. So at Autoscaler, we focus a lot on cluster optimization from a cost point of view. And one of the problems we fight with a lot is how do you detect an over-provisioned state of a cluster? Because that just means you're spending money. And it's a tricky problem to get to, and we noticed after applying error budgets that a similar concept, a performance budget, can actually tackle this problem pretty good. So it's the same exact idea as an error budget, but it's an SLO and performance. So the trade-off now is not with velocity, it's with operational costs. So you spend your performance budget on lowering your operational cost. So it's the same basic idea where you can try to manage your over or under provisioning using a sound engineering metrics. So how would this work? So when you start off, you have a big performance budget. You go with less spare capacity. You kind of live closer to the edge, right? Higher CPU utilizations. You run the risks that a big hit of traffic is going to come through, and you might not be able to scale up as quick. You might use more spot instances. They could go away and affect your performance for a little bit, but it's the same idea, take more risk. Over time, if you do this, you're going to bump up against your SLO, and you're going to spend some of your budget. As you do that, you just start changing your capacity. Go to more of a medium balanced approach. Maybe reduce your use of spot instances, and you should slow down your budget consumption at this point. And you just keep doing this. You keep adding capacity until you maintain your SLO, until you get to the point where you're over provisioned, and then the budget should stop being spent because you have extra capacity. So here's an example of what that would look like. So the green line at the top is the SLO. It's set pretty, like a half a second here. The purple line is the performance budget, and the blue line is the actual response time of the system. So you see it bounces along pretty good, but then there's one little point here where it goes over for just a little bit. It's right during a scale up. So it was basically got hit by some traffic, and we're scaling up, or we're a little bit behind the curve. And the budget goes down a little bit. Same thing happens, it's hard to see, but again, a little bit later during a scale up. But our performance budget is still where we need it, and we're still meeting our SLO, and we're saving some money. Now, here's a question. Is this better? Well, we never bump up against the SLO, but my contention is that's over-provisioned. We are over-exceeding our SLO with extra provisioning that we don't need in order to meet it. So we found most production systems tend to be over-provisioned relative to an SLO, partly because you feel the under-provisioning, things get slow, and you don't feel the over-provisioning because it's just a cost function, right? It's usually rationalized as, oh, yeah, it's a safety net. Yeah, a year ago, we got hit by a big burst of traffic, so we're always ready for it now. But you're overspending when you do that. So right-sized systems typically come in 20 to 30% less on operational costs. And these performance budgets can help you figure it out. Like, how much are we overspending and reclaim those costs? So to flip back at the end, the perfection is the enemy of progress. We talked about the application quality. Higher availability is better, fewer errors is better, and fewer slow responses is better. Hopefully we've busted that as a myth. You actually want to have a few errors and a few slow responses in there. They're important, but they're a trade-off. They're a trade-off with the hidden cost of velocity and operational costs. So that's my presentation. There's my contact info. And I'm also co-starting a SRE meetup locally with Matt. And we will be meeting, not sure where, but if you're interested, contact me, and we'll probably be meeting sometime next month. Thank you.